between the Senate Committee on Governance and Finance and the Senate Committee on Energy, Utility, and Communications. The topic of today's hearing is the role of advanced manufacturing in California's economic future. At the risk of it looking awkward, I want to begin by thanking Senator Woke, Chair of the Governance and Finance Committee, for her partnership in making today's hearing possible. I want to recognize her staff that's put some time and energy into this hearing as well. Unfortunately, she's fallen ill, and I'm hoping I'm not getting the same symptoms. But she's unable to join us today, and I will power through the hearing because I'm actually excited about today's conversation. I want to, in advance, thank my colleagues for joining us. I'm joined on my left by Senator Bill Emerson and Senator Fran Pavley, and I think over the next hour or two we'll be joined here and there by other members of the two policy committees. And I also want to thank in advance the various witnesses who are here to testify and share their information and experience. Just to create the context for today's conversation, if we look back at our state's history, manufacturing has always played an important role in our state's economy. And it should be no surprise. Our state is rich with natural resources that have helped fuel manufacturing for many generations. In the 19th and early 20th centuries, we looked to resources such as lumber, gold, oil, and even our agricultural products as the basis for our economy. Those industries generated the wealth that built our world-class educational system, as well as our state's infrastructure. And it allowed us to move goods and export products around the nation and around the globe. In turn, our education system produced the skilled and educated workers necessary to generate the innovative minds and led California to become the world leader, not just the nation's leader, but the world leader in the fields of aerospace, electronics, and computer manufacturing. For much of the 20th century, our manufacturing sector grew faster than the nation's as a whole. And for those of you who work in the building on a daily or nearly daily basis, get this. In 1977, California was the #1 manufacturing state in the United States of America. Okay, collective sigh. By the 1990s, however, manufacturing growth had stagnated, and in many cases, it outright disappeared. The end of the Cold War saw federal cuts in defense spending, which led to significant downsizing in the aerospace industry, which had a disproportionate impact in the state of California. We also saw rapid industrialization around the globe, particularly in Europe, Asia, and Latin America. And that industrialization and progress drew manufacturers away from our nation and our state because of their significant cost advantages. And since 2001, for the better part of the last decade, California has lost 33% of its manufacturing employment, which translates to a loss of about 625,000 jobs. We're here to reverse that trend. We have an opportunity at this very moment to bring back manufacturing jobs to California and restore the strength of our manufacturing base. Our economy is on a steady, although slow rise. Consumer spending is on the rise, and companies are beginning to hire and expand production. In calendar year 2011, California added 126,000 new jobs, putting us third in the nation behind Texas and New York in job growth. But California's unemployment rate of 10.9%, nearly 11%, tells us that we still have a lot more to do. But we can't just simply wait for job creation to happen. We must proactively seek ways to make it happen. We recognize that around the world, labor standards are on the rise. We recognize that California maintains higher productivity per worker than most nations around the globe. There's an upside to a weaker dollar, and rising transportation costs are also shrinking the cost disparity between manufacturing in California and manufacturing overseas. The result is that we're quickly approaching a point where there will be only a minimal, if any, cost benefit to shipping jobs overseas. The change in international manufacturing has the potential to bring jobs back to the United States. This shift is called reshoring. Industry reports within the last year have estimated that 2 to 3 million manufacturing jobs will be returning to the United States in the next several years. The latest data we have access to suggests the process of reshoring has already begun. 11,000 new manufacturing facilities have been built in the United States since 2007. How many of those in California, you might ask? 178, only 1.5%. And how is that possible? Many legislators know all too well and brag all too often that California has the highest level of private R&D and venture capital investment in the nation. California businesses spend nearly $65 billion in R&D every year, 3 times the amount of the next highest state. Additionally, California is a top recipient of federal government R&D grants to the tune of $15 billion every year. But in California, we have come to a point of a disconnect between inventing products and making products. We're by far the #1 state for innovation, but when it comes to manufacturing investment, we rank 49. California is a global leader in innovation, there's no dispute. But we must also seek to be the global leader in manufacturing. After all, California invented many of the advanced processes, materials, machinery, and software that are attracting the foreign investment and allowing U.S. manufacturers to compete globally. But if we invented it here, we ought to be making it here. And the President of the United States has given us such an incentive. Last summer, President Obama launched the Advanced Manufacturing Partnership to, and I'll quote, invest in the emerging technologies that will create high-quality manufacturing jobs, end quote. The program directs more than $1.5 billion to expand manufacturing capabilities, expedite the production of advanced materials, promote energy and resource efficiency, and provide high-wage jobs. California invented advanced manufacturing. Let's put it to use to bring those jobs back. The President is calling on states to compete for these resources. So part of our discussion today will be focused on what we ought to do as a state to have the strategy and the plan in place to put us in the best position to compete for those federal resources. If we look objectively, it's California's to win, just like Kentucky in the NCAA tournament. Just checking to see if you're still awake. Well, this year, UCLA isn't what it used to be, just like manufacturing. But we can bring that trophy back home sooner rather than later as well. So today we'll hear from our various witnesses about a couple of things. We want to hear details about the President's initiatives. We will get into the specifics of definitions of advanced manufacturing and how companies have adopted advanced manufacturing attributes. We want to discuss what California can do to capture the jobs returning to the United States and grow our economy, because just because we recognize the reshoring of jobs from overseas to our nation doesn't guarantee that they will come to California. The first step is the reshoring dynamics. The second step is putting California in a competitive position compared to our 49 other states. And we also need to discuss how prepared the California workforce is to take on these new jobs. So before calling up our first panel, I want to afford an opportunity for my colleagues to share any opening remarks. Senator Pavley, Emerson, Hancock.
I'll be very brief, and I'm going to apologize. I'm going to be running in and out because I have meetings at the same time. Very important topic, and you started it off exactly where my thoughts have been focused on the last year or two, is how we can make California, which is #1 as far as investment dollars coming to our state. I think since 2006, over $16 billion, over half of comes to the total United States comes right here in California, because we do innovation better than anyone. But how can we take that innovation and expenditure monies in R&D, creating new clean technologies, alternative fuels, renewable energy, and create the jobs right here. We're starting to see some benefit of that. One is in the electric car sector, in that we have 3 electric car companies now calling California home, as well they should be, because we buy about half of the electric cars produced in the country. Some are producing them here, others are not. What kind of incentive program can we offer here in California to attract the jobs through the manufacturing sector that matches our innovation goals? And President Obama has a sort of a U.S. first kind of program going on. I hear mixed feelings on any kind of strategies relating to California first, as it relates to problems with interstate commerce and other kinds of issues. So I welcome comments and things and strategies and suggestions on how we can create manufacturing jobs here, especially I'm interested in the clean tech arena.
Great. Thank you, Senator Pavley. Senator Emerson, Senator Hancock, Senator Fuller.
I would just like to thank Senator Padilla for bringing this forward. I think there's nothing we can do more to promote jobs than to expand on our existing manufacturing base and help them in any way they can be helped, and to promote ways that help us attract manufacturing to use all the engineering and advanced techniques that we have designed here. And you certainly are the people that know how to tell us how to do that. And I too have another committee meeting at the exact same time, so I'll be in and out. But I'm very, very excited that you're bringing this to us today. Thank you.
Okay. If nothing further, let me invite forward Professor David Dornfield from UC Berkeley. Chair in engineering, has been working closely with President Obama's Advanced Manufacturing Partnership. So I'll invite him to set the stage a little bit by describing his specific involvement and the partnership itself. I also want to invite forward representatives from the company Boehringer Ingelheim, an international biotech company which recently opened a facility in Fremont. Representative of Moriseki, a Japanese manufacturer of machine tools, and recently moved to Davis. That was a significant part in garnering Senator Wilk's attention and priority to this issue. I understand we have somebody here from the Boeing Company as well, California Steel Industries, and Kimberly Clark. So specifically, I'm calling forward Chris Qualls, Paul Geary, Adam Hansel, Brett Googe, and Branch Sinkul. You'll have to correct me when you come forward. But we'll start with Professor Dornfield, and let's get this conversation going.
Thank you, Senator Padilla, and please send my the other way. Thank you. Thank you, Senator Padilla, and my thanks also to Senator Wilk and her colleagues, as well as the other senators on the committee, for giving me the opportunity to speak today on what's a very timely topic, advanced manufacturing, as you've mentioned in your opening comments. My name is David Dornfeld, and I'm Professor of Manufacturing Engineering in the Mechanical Engineering Department of UC Berkeley. I direct the Laboratory for Manufacturing and Sustainability, and I'm presently serving as Chair of the Mechanical Engineering Department at Berkeley. I have prepared comments. I don't have any slides, and I think you have a copy of those, so there'll be a few extemporaneous comments, but I think it's the bulk of what I'm going to say is on the prepared comments. Personally, I've been working in the field of advanced manufacturing, education, and research for almost 35 years. I've also, since June of last year, been helping to develop the roadmap for President Obama's Advanced Manufacturing Initiative and Partnership, referred to as AMP, as the co-lead with a colleague from Honeywell of the Advanced Technology Development Workstream, or Task Force. There are 3 other complementary efforts addressing education and workforce development, shared infrastructure, and public policy as part of the AMP activity. AMP was launched in January, as you pointed out, under the U.S. Department of Commerce, with an initial steering committee including 6 universities and 11 U.S. corporations as partners. The final report of this committee will be submitted this April. Thereafter, a nonprofit organization will be created to coordinate and implement AMP. The Obama administration has included $1 billion of new one-time funding in the fiscal year 13 budget that was just submitted, quote, to develop manufacturing technologies with broad applications. It might be helpful to start my remarks with a definition of advanced manufacturing as currently used by federal government agencies, and I note that in the background reading that was provided for the hearing, there were some definitions that were already given, which basically are quite appropriate, especially the one that comes from the President's Advisory Council on Technology. Advanced manufacturing involves and this is one used by AMP, advanced manufacturing involves the manufacture of conventional or novel products through processes that depend on the coordination of information, automation, computation, software, sensing, and networking, and or make use of cutting-edge materials and emerging scientific capabilities, which result in safer and cleaner products and processes protecting human health, the environment, and unintended costs. And I have added the words in bold, these last starting with which result, to the basic definition as manufacturing these days must be done in a sustainable context, and the interaction we have with many companies globally indicate that that's exactly what their objectives are as well. The AMP Steering Committee just met in Washington, D.C. on March 7th to review a final draft report of the 4 AMP task forces. The committee is recommending a focused effort of identification and development of new technologies that will underpin a new era of American leadership in manufacturing. We need to be able to identify and prioritize breakthrough technologies and support the development of these technologies by a solidly formed manufacturing infrastructure. This will also require a deep, well-educated talent pool, as well as policies that foster collaborative manufacturing research and product development. The AMP task force activity has identified a series of specific areas for further investigation and promotion. This has been based on substantial surveying and discussion with industry, manufacturing associations, researchers, etc. I'm going to talk about only 3 of those. The prepared comments list a number, about 10 or so, and there's a few others in the report that will be coming out. The 3 I'm choosing to look at, one is entitled Advancing Materials Design, Synthesis, and Processing, and you referred to this in your opening comments. By way of explanation, this includes nanomaterials, metals, coatings, and ceramics. For example, applications to lightweighting for transportation, automotive sector, aircraft, aerospace sector, such as high-strength to weight ratio materials, high-performance materials for motors or batteries, new materials for special purposes in medical, electronic, defense, energy applications, and some aspects of additive manufacturing to the extent that that applies to the synthesis and fabrication of these advanced materials. You sometimes hear the term materials genome process as well that's used in this area of advanced materials. A second area I'd like to mention specifically, sustainable manufacturing, which is something that we're working on and many companies are pursuing quite aggressively. Usually refers to the efficient production with the efficient use of materials, energy, or other resources like water in an intent to have minimal or no impact on the environment, and also can include things like remanufacturing. And to a great extent, the comments that you mentioned about reshoring can be heavily driven by the efforts to have sustainable production, because in many cases the production processes onshore, especially in California, are substantially more green than they are in other countries that they're presently being conducted. The third area I'll mention is nanomanufacturing, and I include in that precision manufacturing at the nanoscale, such as Zygo Optics in Richmond, which makes precision lenses for the semiconductor industry as well as satellite and other sort of communication and surveillance. This can be both at the nanoscale for processes as well as the nanomaterials. There are several others, including visualization, informatics, and digital manufacturing technologies, so-called art-to-part, or being able to look down the product, the design to production pipeline, that are very heavily of interest and are very well established in California as well historically. So one of the anticipated outcomes of the AMP program will be funding for establishment of a number of manufacturing innovation institutes in the United States. The institutes will serve to bridge the gap between basic research performed in universities and national laboratories and our production enterprises. These institutes would serve as an anchor for technology development, education, and workforce training. So listening to all of this and the background, you might ask, what could California do in the area of advanced manufacturing? I think you've already actually laid out some very good ideas on that. First, there's a tremendous amount of manufacturing, much of it already well advanced, existing in California. But to keep that manufacturing base and ensure it grows here in California and to accommodate future advanced manufacturing, we need to ensure that we have a thriving set of policies, culture, and ecosystem connecting innovation to manufacturing. As a state, we need to enable the scalable manufacturing of products flowing from the creative designers, entrepreneurs, small and large businesses in California. California already is home to a number of national laboratories, leading universities, a very strong educational pipeline in our community colleges and state university systems, etc., that can form the basis of the advanced manufacturing technology development and growth in California. California also leads in efforts to ensure energy and resource efficiency, environmental responsibility, and diversity, all recognized as elements of corporate responsibility by leading California, U.S., and international manufacturers. But we also have some issues to confront as well. The back of my iPhone states designed by Apple in California and assembled in China. This is due to a lack of requisite production technology and components and the cost of doing manufacturing in California and the U.S. But we are increasingly also observing designed or invented in California and made in other places like Kentucky. And I actually didn't know about your reference to Kentucky before I put this in. It is this trend that we need to address by pursuing a coordinated effort to ensure that advanced manufacturing thrives in California so that the people of California enjoy the benefits of a manufacturing workforce. This translates to higher rates of employment and increased tax base, among other benefits for our state. So I think that's the end of my prepared comments, and I'm happy to take questions now or later after the other gentlemen speak.
Any questions at this juncture? I want to welcome Senator Berryhill to the hearing as well. A couple quick questions that are specific for you, not for the whole panel, but we will have when we hear from the other presentations. You mentioned the Advanced Manufacturing Institutes that's called for in the White House initiatives, and there's also the Advanced Manufacturing Hubs. Can you touch a little bit more on both? What the difference between the hub and an institute, and back to the same question of, California, I assume, is not guaranteed to be home or selected for either an institute or a hub, but what can we do to maximize the opportunity for being one of those resource centers?
So I think to some extent in the government parlance, the hubs and institutes are used a bit interchangeably at this point. The AMP proposal is for something called institutes, but the hubs also serve as places in which universities and industries and educational institutions kind of meld together to promote the transition of new technology into productive process. The Department of Energy, in fact, is supporting the development of some hubs. For example, then they call them specifically hubs. There's one on critical materials for energy systems, and that came out of a series of discussions and hearings, but also I think was promoted to some extent by the AMP activity, and that will be a hub on the scale of the artificial photosynthesis hub, the nuclear hub, buildings hub that were done a few times ago, and that was designed to also talk about manufacturing processes as well as materials development. The manufacturing institutes are likely to be distributed on some sort of a competitive basis throughout the United States, and will try to be, I would say, first examples of how this technology of building what in Europe, if you're familiar with something called Fraunhofer Institutes or institutes that liaise between universities and technical organizations, national labs, and industry to try to build this active environment for converting things from innovation into manufacturing technology.
And I know in many ways the details are still being fleshed out as we speak, but can you just give us an example? Here we are, California policymakers, having enough of a sense that we want to be part of this, we want to get ahead of the curve. What are some other states doing to also prepare to be competitive that we ought to be aware of?
So probably the two that come to mind, one is Massachusetts. so there were a series of regional meetings that AMP held. One was held in Northern California jointly between Berkeley and Stanford, because Stanford was another partner. One was held at MIT. One was held at the University of Michigan. So I would say Michigan and MIT are probably, frankly, looking at this the most strategically in terms of how to take advantage of the President's initiative and actually the attention that's now being put on manufacturing in general in the U.S. to both engage companies, engage the states for support and other sorts of policy and activities that help promote the growth, engage students, and of course engage other industries that are involved in it. MIT is doing it, I think, with a very heavy involvement of the state of Massachusetts. They have sort of Route 128, which is kind of their equivalent of the Silicon Valley. And in fact, Marty Schmidt, who's a sort of co-lead of the AMP program under President Hochfeld at MIT, is very heavily involved in that. Michigan, I think, is looking to team up with the more traditional, still advanced, but more traditional industry areas such as automotive primarily, to link closely and to develop something in that area also. The other areas that are being represented, Carnegie Mellon is primarily involved with respect to robotics, and that's a bit of a standalone activity. And Georgia Tech, which is a major influence, of course, in the South and in Georgia, is not quite sure exactly what they're planning to do. But I think probably the major players that would be thinking about this perhaps as aggressively as we are would be Michigan and Massachusetts because of their universities.
Okay, so maybe as a follow-up to the two committees, I'll volunteer my staff to compile information on specific actions and strategies those other states are putting into place and distribute them to all of our offices. Yeah. Senator Berryhill.
Yeah, thank you, Mr. Chairman, and thank all of you for coming here today. I'm looking forward to the discussion. You didn't mention, do you have facilities here in California? Now?
University of California.
Oh,
yes.
University of California. Yeah. Oh, I'm sorry.
We haven't gotten to the companies yet, but
yeah. So do you plan on any facilities coming here in California?
Well, absolutely. The university, many of the campuses of the university, there are very strong programs in manufacturing. So Berkeley, UCLA, Davis are three that come to mind. Number two is those that have some affiliation with the national laboratory, like Lawrence Berkeley or Lawrence Livermore. DOE is putting a lot of resources into the development of demonstration facilities for manufacturing, actually sort of following in the tailwind of AMP. So there's opportunities for those kinds of collaboration. And I think actually, thanks to the AMP activity, and my chancellor, who probably has mentioned the word manufacturing more in the last couple of months than he ever did in his life, because he's leading this activity from the Berkeley side of view, was very much engaged, as well as our Dean of Engineering. And this is, for those of us who have been working in manufacturing for some time, this is a tremendous opportunity to get the attention and kind of help focus resources on this important area.
Yeah. Senator Hancock.
Thank you very much. Yeah, this is a fascinating area, and I'm trying to actually get a handle on what it's going to look like as the AMP project rolls out. Are you anticipating that these advanced manufacturing institutes will be located as a result of RFPs or more informal clusters of research grants, or how are you looking at it?
So that's an excellent question. The Department of Commerce is the program office for AMP, and the Department of Commerce, under its director and a director for manufacturing, are setting up facilities or capabilities to basically put on an RFP, which would be responded to by regions and states to try to compete for one of these institutes. Those details have not actually been very well established yet, because the Department of Commerce and NIST are still actually trying to put those pieces together. But we do expect that there should be on the order of 5 of those. This is all dependent upon funding, et cetera, and sort of congressional activity. And we would expect that, from what we've seen in our early work, that this would be heavily dependent upon the ability of a region or a state to come up with support from a state level, support from industrial partners, and support from the feds as part of this in some form, real or equivalent kinds of support. And it would have to have a particularly unique focus on that region's concerns and competence and capabilities. And one reason I think most of us in California are fairly enthusiastic about, because one of the components is education, and we probably have a better educational pipeline because of the educational plan from community colleges to universities than most others. And as you're going to be hearing, and we're aware of, we have a history and a culture of very strong development in advanced manufacturing. The problem that's probably missing the most, that we'll have to be a little bit more nuanced about and to work on, is this transition, this kind of gap between the research portion and the application portion, part of which is filled by skilled workers, but also part of which is skilled by this ramping up and scale up of processes that actually take it from a prototype to a real process.
Yeah, I was going to ask about the connection between actual investment dollars then to start businesses like Zygo Optics or SunPower or whatever, some of these industries really that we've seen get started in the area. The tie to education and the tie to actual investment money. Are we anticipating government investment money, or are we anticipating private investment dollars then to interface with the research?
I think yes on both. I mean, the $1 billion proposal that President Obama put forward is supposed to provide funding for 5 of these institutes over, say, a 5-year initial period and perhaps extending to 11 years. And I think there's some expectation that there would be continuous resources, but they'd have to be a bit self-supporting. I think they're going to have to be very heavily driven by industry interaction and industry objectives and what industry in the area or in the state feels to be important and significant. And they're going to have to provide, as it were, capabilities, that so-called teaching hospital kind of concept, so that students moving up through the educational pipeline both get exposed to the technology from an experiential point of view in terms of skill set, but also in terms of the culture of working in a manufacturing environment.
Okay, just one other comment, question. I'm interested in the perspective of the panel. In the past, when we say the benefits of a manufacturing workforce, I think you use that terminology. In the past, the benefits have really been primarily, they were good union jobs for people without a very high level of formal education. As we're looking now at much more highly skilled manufacturing jobs. So are we just imagining that we're going to ramp up hundreds of thousands of jobs at a higher skill level and therefore at a higher salary level? So, are you thinking about those interconnections at all?
So those are the critical interconnections. I mean, so I would say the educational level will vary depending upon the industry. For example, one of my students just sent me this email this morning, works at the Zygo Extreme Precision Optics in Richmond, and they're ramping up like crazy, but they're looking for manufacturing engineers, mechatronics, optical, mechanical, as well as CNC, computer numerical control skill sets. So that industry is at the highest end of perhaps advanced manufacturing. There's other industries where there are more traditional roles, which do involve more technology, like machine operators, which would require high school plus some additional education, which could be very good paying, but which are the kind of the workforce that makes the system operate. But the educational experience is going to span all the way across. We're not talking about more engineers from the university system exclusively. We're talking about the entire span. And I think one of the sub-themes of AMP is to try to improve the image of manufacturing, which so far is still in the minds of most people is not anywhere near as exciting as the .com business, and is considered to be sort of dirty and uninspiring. But in fact, if you look at real manufacturing, and especially in many of the companies that are represented at this table, the work is anything but dirty and uninspiring. It's actually quite challenging. So that's a bit of a public relations aspect. But my sense is, and I worked in manufacturing for a very brief time when I was in school, is that if you expose people to the opportunities and you give them the skill set and you show them the culture of manufacturing, it's very rewarding, and it's well paid, and it's something that actually gives you a sense of ownership in a career, which is very useful.
Great. Thank you.
Senator Fuller has some questions, and I'm eager to get to the other panelists as well, but Phil can just make a couple of comments in response to things that I've heard from my colleagues so far. First, I want to emphasize, and correct me if I'm wrong, but the dollars that the administration is bringing to bear, these are not proposed dollars in a future year budget. These are actual dollars in department's budget today, correct?
So there are two sets. There's repurposed money, which is I think 75 million for robotics, and there's some 30 or 40 million from different DOE, and those would be initially available to support some activity. And then there's the 1 billion that's proposed. So there is expected to be some initial money, but it's going to be pretty much repurposed. Perhaps the newest of the repurposed money, at least what I can see, is from the Department of Commerce through NIST. The others are pretty well moved from other areas and are kind of earmarked for certain activities.
So at a minimum, we have a down payment that's not
exactly
dependent on congressional approval.
Exactly.
Second, this as I've engaged in conversations about advanced manufacturing, some people are thinking, well, are these companies we haven't heard of, or what's the new gadget, what's the new product, what's the new, that may be the case for some new technologies that come to life in future years, but in a lot of instances, maybe the majority of instances, we're talking about existing companies or existing products being done in a new way. And therefore, the challenge of getting the definition right, because it's not something you can point to and say, aha, that's advanced manufacturing, that isn't. It's more a systems and a processes question. And just an acknowledgement of Senator Hancock's question about what skill level or educational level are we talking about with these potential new jobs. Part of our challenge here is threading the needle. When we talk about this reshoring effect, there's a number of industries where we are much more competitive than others. When we talk about, is there still an incentive or disincentive for a company to set up shop in India or China or anywhere else versus looking at the United States realistically again? In some products, the labor cost is still a driving factor, and the transportation logistics cost not so much. In other cases, that's not the case. So we're looking specifically at the areas where California has its strong suits, and the more sophisticated areas of manufacturing, the advanced manufacturing as we propose to be defined, is sort of a sweet spot for California if we can do a couple things to be competitive with other states. Senator Fuller.
So just real quick, since there are two programs, sort of one is, how, for the programs that have repurposed money, it sounds like all of the states will be applying, or are we applying as a state, or are businesses applying, or how do our industries access that $75 million?
So I think what's going to happen is there'll be an RFP. There will be groups of universities, industries, regional agencies and organizations that will get together, and we'll look at if they have a good story, a common activity, and they will apply for some of that. So I don't think that level of detail has been worked out, but I think it's going to be typical of most RFP processes, where they'll be looking for a best case scenario, and they'll be competitive based upon what resources are brought to the table by the partners, what kind of a new area, and what kind of perhaps business plan, or what's the payback that they're expected to see. How well is it connected to the local educational infrastructure, even though funding will not go, I don't believe will go to education, but how well is it connected to an infrastructure? What kind of activities are going on in the state to be supportive of this, and sort of that kind of usual mix of activities.
And then secondarily, just out of curiosity, has there been any discussion about a lot of the discussion here that's coming is about reshoring, and so is there outreach to offshore businesses we'd like to have come back, or that their parent companies move some part over there as proposed in the second part of the funding, or maybe even the first?
So in the final report, which I can't share with you today, but one of the specific questions that was asked most of the industries is, what is it that makes you offshore, and what would it do to make you reshore? And the answers are complicated. It's not always low labor. It's if your market is there, you're going to build there. But the list of technology areas that they thought were things that should be pursued are things that would allow more reshoring or more development of existing. And just to comment, if I may, Senator Padilla, one of the comments about what is one of California's real advantages on one of the reshoring options has to do with environmental issues, carbon footprint. California has an exceptionally green electricity mix, and that which could be on essentially sort of 7 times greener than China, for example, twice as green as Kentucky. So when eventually companies are looking at touting that as a competitive advantage, either by regulation or by consumer demand or just because of competitiveness issues or because they want to sell things in the European Union, eventually those kinds of externalized costs will be shown up in the bottom line, and that will make it an advantage. So you building an electric car in a state using electricity that is inherently greener than most other sources makes the carbon footprint of that product much smaller. So that's an advantage that we have.
Thank you.
Great. Let's now turn to our industry representatives. Let's start with Mr. Qualls.
Okay, I'd like to start by thanking for the opportunity to speak before you today. I appreciate it. I also am a California native, and so I share in your passion for the well-being of this state. So today, what I plan on doing is sharing with you a little information on Boehringer Ingelheim, a company that I only recently joined in the last year. And I'll tell you a little bit about what the company is about, and then move on to our manufacturing operations here in California and some of the technical aspects of that and some of the challenges that we seek. So in terms of who is BI, it's a family-owned corporation. It is one of the largest family-owned companies in Germany. And is the largest family-owned biotech company in the world. And so they've been around since 1885, quite respectable length of time, and employ a large number of people, 42,000, have 20 facilities in 13 countries, and total revenue of about $17 billion or euros, which is, again, a respectable amount. In terms of total net sales, the company is diversified into 4 basic areas. The lion's share of net sales comes from prescription medicines, and the Fremont facility, which I'll explain a little more about, is part of the biotechnology group and falls into that prescriptions medicine spend. You can see they've also diversified to some extent in consumer healthcare, animal health, and then industrial chemicals as well. The other noteworthy thing about BI is over 75% of the revenue that they generate actually comes from the United States. So it's an interesting dynamic considering they're our European company. So if we take a look at the therapeutic areas, they target 6 therapeutic areas. All of them are typically chronic therapies, and also I think that have a profound effect on patients' lives. And so that is really a very strong flag the company flies, is making sure that we're doing the things necessary to really advance the industry and serve the patients, because we all know that in today's world there's quite a high demand for remedies. In terms of the history of the company, BI was one of the pioneering biotech companies back in the early 60s working on chicken interferons, and then kept in the biotech game. Although chemicals, I think, originally was a larger portion of their business, BI had the foresight and the vision to see that human therapeutics long-term would be a better way to grow the business, but also to have a goal that I think is admirable. And because it's a family-based company, I think that rings true through the organization. So BI continued to work on their own product portfolio, but at the same time, started to partner with other companies, as many startup companies do. And eventually built their own plants to serve primarily their own products. Later, they had also been working with a company I'm sure you're familiar with, which is Genentech, on some joint product development efforts. And Genentech encouraged them to go into the contract manufacturing business also. And so now a large portion of BI's revenue also is generated from contract manufacturing. So not only do they make products for themselves, but they also manufacture products for other people. Here in California at the Fremont plant, we do both. So BI's business continued to grow, and then in 2010, they made a decision to really globalize, and that was, I think, a defining moment in the company where they really saw that above all other sectors of business that they had, that they really wanted to invest in the biotechnology. And so that led to the acquisition of the Fremont plant, which was about 12 months ago. Now, why did they want to go to Fremont? Fremont, you know, when we talk about reshoring and things like that, I think this is an interesting case study because BI sees the intellectual talent and the innovation that comes out of places like California, and that's very appealing to them, and they see that as a competitive advantage in the marketplace. Additionally, they plan to expand into China, and California provides a very nice jump spot for us to train people, increase the education, let them practice, and then send people over to China. And because the majority of their market share is in the United States, I think that you know, it's bringing home some of that manufacturing and development work. So as we talk a little bit about the facility in Fremont, we occupy about 400,000 square feet there. 200,000 of it is dedicated to manufacturing space, and I'll get a little more into this as we go through the slides. In terms of staffing, we have 300 full-time employees and also use supplemental workers because there are a lot of services that are provided to the plant that we don't do ourselves, so we also supply opportunities for a lot of local people just through service provision. The average salary is about $90,000, and I think this is a noteworthy place to comment on Senator Hancock's earlier remark around what is the demographic of job provision for advanced manufacturing type roles. And so I think it's noteworthy to keep in mind that even though, you know, we consider biotechnology advanced manufacturing, and we hire a lot of scientists and engineers and you know, higher educated people, the reality is that there is an entire bevy of other people that are required to support the work that they do. So it's an interesting ratio. If you are able to create a job in advanced manufacturing and hire those top-notch people to fill that and do the innovative work and do the development work, there is a significant amount of other people that are required to support that activity. So I think it provides a nice blend of opportunity across the spectrum. About 80% of the folks that we have college degrees, and about 25% of them at the master's or PhD level. In terms of our manufacturing facility at Fremont, we make both clinical and commercial products. We also do a lot of early development work, so we offer a full spectrum of services for mammalian biotechnology opportunities, anything from cell line development, which requires a lot of lab activity, a lot of analytical work, where you're optimizing cell lines to do the things that we expect them to, all the way through scale up, and then ultimately clinical, and then if the product is successful, commercial manufacturing. Another noteworthy thing about our plant is its design incorporated a very unique concept in pharmaceutical and biotechnology manufacturing facilities, in that there's an entire glass wall that runs around one face of the manufacturing plant So it's really nice to be able to walk around without having to put your gown and mask and hood on and go inside. You can really see people working, and it provides a really nice training opportunity, even to the extent that the FDA has come and trained inspectors there. And so it's really something to be proud of. The other noteworthy thing about Boehringer, as we talk about the contract manufacturing business, is that BI is one of the largest contract manufacturers also. In terms of our manufacturing operations, it's essentially split into 2 trains, and I will explain the process in a little bit. There are 4 basic steps where we have inoculum, where we're just starting to grow the cells, and then we move into the fermentation, which is the actual production phase where we're starting to generate proteins. And then there's purification, and then we prepare the product for formulation. And here you can see a little more about that. And so this is a diagram that just kind of shows the basic processing steps that we go through. And when we start, and I think what makes biotechnology really distinctly different than traditional pharma is we're not just mixing compounds and things like that are, I think, just a little more understandable and discrete. When you start to get into living cells and then modifying those cells to produce specific proteins that you're looking to harvest, those therapeutic proteins, now we're starting to deal with living organisms, and the game kind of changes a little bit at that point. And so what we do is we take a vial, which is a typical ampule, glass ampule type vial, that has some cells in it. Now those cells have already gone through the process development process and have been optimized to express a certain protein. And then basically we just make them happy and allow them to grow. And they will multiply to a point where we either stop around the 2,000 liter scale, or depending on the titer and yield, maybe the 12,000 liter scale. And at that point, what we do is harvest. The cells have been expressing the protein, which is now in the liquid. And we take that and go through a series of separation and purification processes so that we purify the protein, the target protein that we're looking for. And then that is eventually put in with a formulation buffer, and that goes into a vial or a syringe or something like that. Primarily, the products that we make are injectables, and there's a few different ways that you can package injectables. So if we take a look at the finish forms that BI offers people, it's essentially in bags and then in a variety of syringes, pens, and then spray drying for those traditional pharmaceuticals and vials. In Fremont, we deal exclusively with bags and vials. So as we talked about earlier, it's not just the manufacturing process and the jobs created around manufacturing. It's really about the whole spectrum of things. One noteworthy thing is, I think for every manufacturing job we create, the ratio is about 1-to-1 for a quality representative to either help manage our compliance or patient safety attributes to make sure that we're in proper control of the manufacturing process. And so there's a lot of opportunities in that regard as well. Provides more diversity in the workforce. So specifically at the plant in Fremont, right now we have currently planned about $150 million in improvements to the plant. And this is just to keep current with all the migrating technology. I think, process controls, which you mentioned a few efforts and companies that you were working with earlier, they're very important to us. And so every time we upgrade, it also drives technology and demand in a lot of different areas that are also considered high-tech industries as well. Our production is technically complex, like I tried to explain, because we're dealing with biological organisms, so it's not just cut and dry, mix and go. And that requires innovative products to help manage the attributes and the parameters that they require. We also have a lot of special requirements, and they're regulatory requirements and engineering details where we need to control the environment. And all of that takes a labor and skill set that tends to be a little more on the upper end of the education scale. That doesn't go without saying, though, about all the support people that it takes just to keep the space going. So when we talk about challenges, one of the things that I think we all understand is that every time, me specifically, I have to obtain funding for expansion. And right now, Behringer is looking at additional manufacturing opportunities in California because they really see California as an ideal place to do business. But one of the challenges is that we always have to explain why the economics are different here and then overcome, those things. Because we have a high degree of technology and usage of what I would call, advanced products or leading technology, the cost of those is pretty high. And so, anything that we can do to help minimize that cost so that we can reshore and make it economically feasible, it seems as though that people have a high interest in being here, and whatever we can do to serve that would be definitely useful. Thank you.
Okay, thank you very much. I want to go a little bit out of order here. I understand Mr. Googe.
I just changed my flight.
Oh, did you?
Yeah.
Okay.
No worries.
All right.
He's going to move.
They don't want you to miss your flight, but if you change it, then we'll be here all night.
Yeah.
Then let's go to Paul Geary from the Boeing Company next.
All right, thank you. Thank you, Senator Padilla. I want to also thank Senator Walk and the members of the rest of the committee. I'm really proud to be here today to speak on behalf of the Boeing Company. We have 20,500 employees in California, and as you mentioned earlier, that's been on the decline for the last 10 to 12 years. I think you mentioned a 30-some% reduction. That's about a 50% reduction to where we were about 10 years ago in the 40,000. So as a few of the members of the panel, I'm a native Californian. I grew up here in Sacramento, and I got my engineering degree from Cal State Long Beach. Now, it's not an MIT, but we did make it to the NC2A tournament this year, even though we lost in the first round. But I'm the vice president and program manager for a program called the Family of Advanced Beyond Line of Sight Terminals. It's an Air Force program. We provide the command and control infrastructure for the U.S. Air Force and the U.S. President in the event of a U.S. command and control strike using our nuclear forces. So very, very important capability for our nation, and I am the program manager for that for the Boeing Company. I work out of my office is in Huntington Beach, California. And today I'm going to provide you a little bit of a high-level overview, some prepared comments about what Boeing does in California, addressing some of the topics that the committee invited us to address, such as the role of the aerospace industry in enhancing advanced manufacturing in the state of California. I mentioned we have 20,500 employees in California. We work in more than 50 locations within the state of California. But the focus is on three major sites. El Segundo, where we do space satellite manufacturing. Long Beach, which is the home of the C-17 airplane manufacturing assembly, which is one of our heritage aircraft for the United States Air Force, as well as now internationally. And then in Huntington Beach, which our heritage is in the space, command and control, communications type of business. We have some 5,700 suppliers to the Boeing Company in the state of California, and about $6.2 billion in sourcing goes to those suppliers in California. So Boeing is a big supporter of the state of California in lots of different ways, not only in our own employees, but also in the revenue we spend here in the state of California. And we have about 55,000 retirees that still live in the state of California, and we're happy to have them in a defined pension plan and really being a robust part of the economy. So that's a very good situation that we're proud of. So what is advanced manufacturing from a Boeing company's perspective? So we look at it in two ways. There's manufacturing of advanced capabilities, products, and technologies, and I'll talk a little bit about those. But there's also advanced manufacturing techniques, tools, processes, and approaches that allow us to be more cost competitive and attractive and to make a widget for lower dollars. So both of those are important, I think, as we look at the definition of advanced manufacturing. In Huntington Beach, we manufacture advanced composite parts for aircraft and space applications. We develop leading-edge technologies such as thermal protection system capabilities for space vehicles. Huntington Beach is also the home of our advanced communications and command and control systems. And in addition to these specific product lines, we're using leading-edge manufacturing technologies for rapid prototyping of complex parts. We use fused deposition modeling and adaptive fabrication technology in order to be able to take a part off the design board and put it into a product in the matter of hours or days rather than weeks or months, so that we can take advantage of not only the design tools but also rapid manufacturing techniques to be able to play parts into a complicated assembly. So what do we see as issues and solutions in the near term? Well, we feel that the spirit of innovation is alive and flourishing in Boeing, and certainly our ability to thrive in California is probably more challenged than elsewhere within the U.S. from a Boeing company perspective. There are some near-term issues that are impacting Boeing's California workforce. Since 2000, as I mentioned, the Boeing workforce in California shrunk from about 40,000 employees to about 20,500 today. Now, some of this is attributable to merging and integration of the various heritage companies that make up the Boeing company. But the headcount decline is really probably more symptomatic of a more serious problem, and that is the cost of doing business in California. A recent example for us was the move of our B-1B program from Long Beach to Oklahoma. The B-1 bomber was designed and built in California, and it was not an easy decision for Boeing to make to take and move the work and the workforce to Oklahoma. But as Boeing reviewed the anticipated operating costs for the next several years, it became clear that major actions were needed to remain affordable for our customer, the U.S. government. And the same cost barriers can come into play when the company looks at new programs and new services, both on the military and the commercial side of our business, and when we look at where to place that work. The challenges of doing business in California are not unique to Boeing and have well been cataloged. It is for these reasons that we applaud last year's rollout of the Lieutenant Governor Gavin Newsom's Economic Development Plan as a good start. The plan proposes solutions to many of the issues businesses face in California, such as cumbersome and complex regulatory environment that I think we all agree needs some level of streamlining. For example, the state imposes additional and unique rules regarding the workplace that necessitate specialized training classes for Boeing employees located here that many other states that I have employees working for me do not impose. So for us, support for the manufacturers, which I think is a linchpin of the U.S. economy, is another area that the Lieutenant Governor's Economic Development Plan addresses. California is one of only a few states that taxes manufacturers on job-creating investments in plant and equipment. So toward the end of the 2011 legislative session, Governor Brown proposed an economic development plan that provided a manufacturing investment credit for investments made for manufacturing, and we support that, and we're proud to be part of that governor's plan. This type of measure would help stimulate manufacturing in the state. So what about the future workforce? So we talked about kind of some of the challenges, where we've been, what the problems have been, but I think as we really want to focus this advanced manufacturing idea, we want to think about the future. So we've talked about the programs and operations and how innovation is at the core of what Boeing does and what we are. The embodiment that innovation is part of our workforce is really important. We employ 159,000 people across the United States and some 70 other countries. And 123,000 of those employees hold college degrees, much like some of my colleagues here, a very high degree of education. And 32,000 of those are advanced degrees. So in virtually every business and technical field, we have people from approximately 2,700 colleges and universities worldwide, and engineers make up a little more than 30% of our workforce. But as the baby boomers have started to retire, we, like many other advanced technology companies, are facing an impending skills shortage. The Aerospace Industries Association estimates that while the U.S. graduates approximately 70,000 engineers each year, only 44,000 of those are eligible for work in aerospace due to security clearance requirements or of those natures. So that's also a challenge for us in the future. So in summary, look into the future. Everyone is familiar with the painful process that this country and our state is undergoing to address the debt issues, the affordability challenges, the attempt to regain this solid economic footing that we once prospered under. And I think this idea of reshoring fits very well where we want to go. Boeing has anticipated flattening defense budgets based on where the U.S. DOD is heading and with the U.S. government's budget woes. So we've had to look at maximizing our efficiencies, the way we do business, drive for a more affordable, more productive workforce. We've been positioning ourselves for this and working toward a growth by working on international opportunities, as well as moving into new markets that we previously did not address. And our immediate focus is on emphasizing the relevance of our programs and Boeing's performance in delivering them to our customers at the best value for our taxpayers. Certainly, there is no question the aerospace industry is undergoing a transformation, and the needs of our customers are changing and evolving. We're having to change too. There is no such thing as a tradition or the status quo in aerospace. We must always be thinking creatively to maintain our competitive edge and design and build products that will meet the needs of our customers. Likewise, I think it's open for the committee to hear that the state of California can also adapt and take steps that are necessary to protect its manufacturing base, which has served as one of the state's primary economic drivers throughout the history. For example, I think implementing a manufacturing investment credit that exempts equipment purchased to manufacturing goods from state sales tax is a good idea. This type of credit has proven effective and is already provided in many other states. Implementing a quality jobs program, similar to states such as Oklahoma and Missouri. Under those programs, companies are allowed to retain a portion of the state withholding tax for new jobs that are created, provided they meet certain income and health insurance requirements. The Oklahoma program, for instance, led to nearly 1,000 jobs in that state for Boeing. And then finally, incentivizing California companies to do business and award contracts to California suppliers. So Boeing has over, as I mentioned, over 5,700 suppliers in California and invests over $6 billion annually. Maybe there's an opportunity to incentivize that kind of a flow down as well for manufacturing in the state. So for Boeing in California, while it is true that our footprint is smaller than it has been previously, it is still significant. We're passionate about work in California. As I mentioned, I'm a native. I want to keep the jobs here. We remain committed to being a good neighbor and reaching out to the communities where we live and work, and to continue to strive to make California a great state as it can be. And so thank you again for your opportunity to be here and contribute.
Thank you very much. Adam Hensel's next.
So my company, Moriseki, is very honored to be here today, so thank you for the invitation. I want to briefly mention that I guess we had three questions. Why is there industry in advanced manufacturing industry? what processes does your organization use and what are some of the challenges. And 10 minutes is really difficult to go through that. So we're right down the road in Davis. We're building a new manufacturing facility there. And I want to just extend the invitation to anybody here. Come out if you want to see what we're doing and some of the challenges we face and some of the things we're doing on the advanced manufacturing side. And it's a small world, too. I didn't know one of the professors we sponsor as a company happens to be Dr. Dornfeld. So give credit where credit is due. This slide comes directly from his research. I wanted to first mention the advanced manufacturing. We need to be careful with this definition. I would almost say that everybody in manufacturing now has to be advanced if they want to survive. It's driven by the consumer industry or whatever. Nobody can do it like they did 10 years ago and expect to make money. The margins aren't there. And also when we look at manufacturing, I know a lot of it has been made of the clean tech industry and so on, but it's very important that we look at the whole process chain, the whole product life cycle from the resource extraction all the way to the end user. If we focus on just one aspect, we're leaving 5 or 6 pieces out of the puzzle, and that's a huge opportunity wasted for California. Our company, The Circle here, is mainly involved in the manufacturing end of it. So we make CNC machine tools. What are CNC machine tools? Well, they're milling machines that make parts by a subtractive process, and they're controlled by some relatively complex mathematics. And they're one of the fundamental building blocks of manufacturing. In fact, some of the companies here that are presenting, pharmaceuticals, medical, aerospace, our product will be sold to these companies to help make their parts. Briefly, to have good manufacturing, you have to have good design. So we do a lot on the development activity side. We develop the machine tool, of course, but advanced manufacturing is also how quickly and how you can make something and how productive you are making it. So we focus on a lot of automation in our machine tools, and also a lot of the productivity to use the machine tool. What's the use of making something great if the user can't use it very easily? I think maybe that's one of the strengths of the iPhone and why everybody likes it, because it's so easy to use. So we focus on that a lot. Advanced manufacturing for us I could go on for hours here about different examples, but I'm going to just show you a couple real quickly. This is something that everybody can easily recognize, a jet turbine. New materials are needed to make this. Boeing, I think, using a lot of composites on the 787 and so on. So we're making machines and processes that can facilitate those new materials. This is one of our technologies. We call it zero chip. Basically, we have a very powerful vacuum that sucks the waste of the cutting directly through the spindle and into a closed container. And very powerful technology for composites, because you don't want all that dust floating around and people breathing it and so on. So it helps that process to be a lot more effective. I mentioned automation. Here's one example of an automated cell. So people used to think of a machine tool, one person standing in front of it, operating it, and that's the skilled labor that's running that machine tool. That's not the case anymore. Cells are becoming highly automated, so you have to think about a robot loading it. You have to think about automation that hooks into your ERP system, like with your barcoder, and then scanning the part, measuring it once it comes off the machine, all in an automated process. So that's the other thing we do. We try to give our customers a full solution together, rather than just the machine tool. So the idea of skilled workers, I'll maybe address that as one of our challenges later, but the idea is that there are a lot less so-called button pushers. To run the more sophisticated equipment that's being produced does require higher education. There's a gap there, and we need to address it. I don't think you can have a discussion on advanced manufacturing without talking about what's going on to reduce the energy consumption. Nowadays, it's becoming more mainstream. Obviously, using less energy means people spend less money, so it's good for business and good for the environment as well. This is the machine that we're going to be making in Davis. Over previous models, this particular machine, through energy-saving techniques, we've been able to reduce the power consumption for a single part by approximately 40%. These next several slides are also from the result of Dr. Dornfeld's research. So I'm going to ask him to correct me if I don't give it due justice. But past processes have had a tremendous amount of embedded energy or tear energy. And that means embedded energy such as the HVAC in your facility. The lights are on. When your machine is idle, you're not making something, it's still consuming energy just because it exists. So the other thing along with that is when we have past processes would be made on one type of machine, then to get the next process, you'd put it on a drilling machine and then a turning machine, and so on. So you have all these processes. While you're transporting the part between machines, it consumes a lot of energy. And that embedded energy we were talking about with lights on and HVAC and so on, that keeps running. Pumps on the machine keep running, the electronics are turned on, and so on. So what you want to do is maximize your spindle time. So even if you design a machine that consumes a lot more energy for the amount of time that it's running, if you can consolidate processes, what happens is you reduce all that tear time between processes, and you dramatically reduce the amount of energy consumed per part. This is very important, staying competitive in the manufacturing environment. And I think in California, especially where people are putting an emphasis on the green technology side. Okay? Good. So we're on Google now in Davis, so that officially means we exist, I suppose. We've had an R&D facility there for some time, and now we're building a manufacturing facility. The manufacturing facility is going to make the machine tool I just mentioned, and it's about 200,000 square foot facility. And for machine tool manufacturing plant, it's going to be state of the art and use a lot of the latest technologies. And I really don't have time to talk about them in detail today. But one of them is a big automation system. It's called a linear pallet pool system, where we have machines that are fed by more or less a robot. And so the operators are able to load these up, all the parts, and put them in the queue. And as one machine finishes, another part goes in. So we can run these machines 24/7 without people standing next to them. And this is something that we want to use as a showcase for potential customers to see how to improve their processes as well. Real quick on that factory, we're expecting to hire around 150. Our payroll target, we want to be sustainable, so we want to be above the average, but not in the top tier. We'll be able to produce about 80 machines a month at maximum capacity, and our local procurement ratio is about 45%. I have a slide on that later. Gross sales could be up to $160 million. And the investment we put in to do this, not including the land, but the construction of the facility itself, is about $27 million, and the capital equipment we're putting in there is another $25 million. So here's the last part, challenges. The California tax and business environment is maybe pointed out by some to be a little bit difficult, but maybe more importantly is the supply chain. I don't think you can manufacture something effectively without a very strong supply chain. And this is not the best place for a supply chain for manufactured parts. We'd like to see that small manufacturers, say 50 people or less, companies with 50 people or less, become stronger, because that's what's feeding all the bigger companies. It really is. In fact, half of our customers, the people that buy Moriseki machines, we don't sell everything to Boeing or Caterpillar or whatever. Half of our customers are job shops with 50 people or less. And those are the people that are actually the Tier 1, Tier 2, Tier 3 to all the automotive, aerospace, and so on. Available employees, this goes with the training issue. Incentive package, or I should say maybe lack thereof. California wasn't the only place that was considered for this factory. In fact, the main competitor was Illinois. And Illinois offered us a very, very strong incentive package. They offered us the land for $1, and they had a lot of tax breaks and so on. And we did things differently than most other companies. This is where we're different. We built a R&D facility here 11 years ago, and we did well with that, and we expanded it. And after building the R&D facility, we decided to bring in the manufacturing. I think this is backwards from the way most things work. Most people are going to bring in manufacturing first. And I can tell you that without the R&D facility being here, the manufacturing plant would not have gone here. I talked about very briefly the U.S.-made parts. We definitely want to increase this ratio from 45%. Some of the components are built in our Japanese factories, so we'll keep doing that. But we do source some parts from China and so on. We'd like to see that go up to 70% procured locally if we can start to establish a stronger supply chain. And training. California's done a nice job on this with the training credit. And I actually don't know the current status of this, but I'd like to see it go on. We've taken the stance that the skilled laborers are not available. To make a piece of precision equipment such as ours, where we're holding tolerances on the area of 5 micrometers, it takes a lot of skill, and we don't find that. The machine tool industry in the U.S. with Cincinnati and Bridgeport and so on is gone, and those people that worked there before are at retirement age. So we don't have a pool to pull from. We have no shortage of resumes turned in, but we've taken the approach that we have to do the training ourselves. So we're actually assuming our factory is going to be a manufacturing university for our own purpose. And we don't expect to be at full capacity for the first 3 years because of it. So this is something that I think California had a good take on in the past, but I'd like to see some effort go into having some kind of training incentive. And I think that does it for me.
And before we go on to the next presenter, I think that just speaks to an issue that Senator Hancock raised earlier about the time between industry, the potential in the industry, but the education responsibility the state has for the coming workforce, not just the current workforce. Brett, you're up.
Thank you. Who's on? I believe it is. We're one of those companies that Dr. Dornfeld referred to as a traditional company employing advanced manufacturing techniques. We wouldn't be alive without advanced manufacturing techniques. We would not have survived our many years in business. We are the largest steel company in the western U.S., which California Steel down in Fontana. We produce carbon steel sheet and tubular products. Let's see, I think I have a presentation somewhere there. Sorry.
Did it get uploaded?
Well, do you have the handouts?
Yeah.
Okay, we'll just go with that. Thank you. We have 200 active customers, most of whom are in California, most of whom are not big businesses either. As Adam mentioned, his customers are not. And since 1984, we have employed and invested more than $900 million in capital here at our site in California. Our roughly 1,000 employees on site about 50% of them are minorities. They are all high school graduate or above, and we are consistently trying to bring more college graduates in to actually work on the manufacturing floor because of the advanced technology requirements that we have. We actually pay a premium to hire college graduates for production work. We also are recruiting heavily out of the Navy and other military services for people with technical backgrounds that just aren't available anywhere else in the workforce unless we train them ourselves or the military has trained them. So it's a huge issue to staff with the right kind of technical skills. Our average pay is about $60,000 with strong benefits and profit sharing on top of that, and we have worked 27 years and counting with no layoffs. Even during the depths of the recession, we were able to find work for people even in the community to keep them busy, and then we were ready to come back as the economy rebounded, and were able to take advantage of business coming back. Oh, that's all right. Our business model is one that kind of developed over the years. Originally on our site was a company called Kaiser Steel, which was an integrated steel company, and they went out of business in '83. We were formed in '84, and rather than make steel, we buy steel. We buy steel in the form of 20-ton steel slabs, and we convert it to various forms of steel sheet, which can then be stamped and rolled and processed into many, many products. We make some of that into pipe, which has been a very good business for us, especially with the gas shale plays that you hear about. The energy market has been very strong, and that has really helped us come out of the recession much quicker than if we had to depend on our traditional construction markets. When you look at the next slide, which is the integrated mill versus our model, and we're the back end of the integrated mill, I guess. The integrated mill takes iron ore, makes iron and then steel, and casts it into a slab, and then uses that slab internally, rolls it into sheet. We simply buy the slabs. So when you look at that, we're on the bottom half of the page. We buy the slabs, roll them into sheet, and the nice thing about that is we have basically exported most of the pollution and the greenhouse gas production out of this process. We don't do it in California. When we buy the slabs, 90% of that has already been expended. So we only create 10% of the greenhouse gas to make a coil of steel here in California. We're a big customer of the Port of Los Angeles. I just mention it because of the fact that there's a tremendous ripple effect by the work that we do with the railroads, the truckers, the ports, and so forth, highly dependent on each other. And many, many jobs are at stake based on how well we do in our company. If you look at the end uses of CSI products, too many to name, but here are some good examples, and you'll see a lot of construction. Certainly one of the new products that we're selling into quite a bit now are solar applications, solar thermal, large solar farms, and the actual framework for solar panels. I mention our market area for this reason. We typically sell as far east as the Mississippi River, but our target market is the western U.S. And the point here is, without the ability to compete outside of California, we couldn't survive. You know, you don't build a steel mill just sized to meet the state requirements. You build a steel mill to serve a geographical region that transportation costs can bear. And we have some of the highest cost electricity in the nation of any steel mill, if not the highest. Many of our environmental permitting costs and things are completely off scale compared to other states. We don't have the incentives to invest in capital here in California that other states have. And yet, we're here in California, we aren't going anywhere, and we serve not only California, but the entire western U.S. And we have to compete against our back east competitors, domestic, our global competitors from Asia particularly, and we have to be able to compete and still bear those California costs, those California unique costs. And that is a challenge, and if you can't be advanced in your manufacturing, you can't do that, and that is a fact. If you look at what we've invested, I mentioned the $900 million. Here are just some of the pictures of some of the beautiful, highly advanced equipment that we've installed over the years and some of our bigger capital investments. And I'll remind you that these capital investments that you see here were certainly incentivized by the Manufacturers Investment Tax Credit that expired in 2003, which paid 6% on capital investment and 6% on the labor expense of all of these installations, and certainly was a factor in decisions to install these highly advanced technical improvements to our facility. All of these improvements that you see that I'm showing here, some of our bigger ones, were for quality, efficiency, and market development. None of them were for increased production. None of them increased our capacity. They simply met the market need, and they simply met the efficiency need required to survive and thrive in California. If you look at any of our mills today, you'll see not only a lot of dynamic decision making by the employees, you'll see them operating some very sophisticated computer-controlled equipment, robotic coil transfer equipment. We are a consumer of advanced technology, or we wouldn't be alive. We also finally did invest in some additional capacity. I mentioned those other investments were not for capacity. During the depths of the recession, we actually spent $71 million to add a state-of-the-art slab reheat furnace. We're pretty excited about it. It increases our capacity 50% with much lower emissions. We believe it is the most modern and environmentally effective reheat furnace of its type in the nation, if not in the world. Greenhouse gas emissions were reduced per ton by approximately 20%. NOx emissions were reduced in whole by about almost 70%, and particulate matter emissions reduced by about 20%. And here's a picture of one of our beautiful slabs being ejected to be rolled into sheet out of that new reheat furnace. When you look at our history of these investments we've made, the red line you see in this chart, going back to 1990, and I use 1990 as an important year for all of us because now we're facing AB 32, and that's kind of a benchmark that we're being asked as a state to get back to on greenhouse gas emissions. If you look at our performance over the years, the red line's our steel production. You can see how it went up, 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 up as we grew with California. You can see how it went down sharply in the recession. And you can see our greenhouse gas production, which has remained basically flat except for the recession period. And I think that just speaks to exactly what I've been talking about in terms of an advanced manufacturer has to do this sort of productivity increase and efficiency increase to survive. You don't have any other choice. Advanced manufacturing companies that sell their technology need companies like California Steel. This is why it's important. For every job formed in the steel industry, 7 additional jobs, high-value jobs, are created in other economic sectors. We've demonstrated that time and time again. We are characterized by the kind of capital investments that you are considering for advanced manufacturing. I hope that you are able to see that picture as broadly as we think we do in terms of we aren't just your father's steel industry, and advanced manufacturing companies need us. And I also will finally comment that steel is the most recycled material on the planet. Adam mentioned earlier, as you look at this issue, look at product life cycles. Steel is used over and over and over again. It's a kind of material that often, when you look at the recycled content, really does have a pretty strong environmental impact in a positive way. Thank you very much.
Thank you. And last but not least, Kimberly Clark.
You want to sit here? Sure.
Mr. Chairman and members, if you'll suffer a quick setup of props here. I know it was difficult to get an airplane and sheet metal into the building, so this wanted to represent all of us with these products. I'll explain what these are. This is not a bomb. I promise security makes certain that it was very safe when we brought it in. Mr. Chairman, members of the committee, my name is Branch Senkule. I'm with Kimberly-Clark Corporation. I want to thank you, Chairman Padilla, very much for introducing the Advanced Manufacturing Incentive Bill. I think it's going to, as it's already begun, is sparking a wonderful dialogue about the future of manufacturing in the state of California. If you'll indulge me with a very brief run-through of what Kimberly-Clark's profile is as a global company, given some of these products you see from the brands noted there, our business model is to make product wherever possible where we sell it, in proximity to where we sell it, rather than ship bath tissue, facial tissue, bulky items like that over large distances. We save on, obviously, on fuel, environmental impacts, and we think it's helpful to provide employment places where we are selling product because it brings more of a connection, we think, for consumers to the product. Don't want to go through too much of the data there, but you can see, hopefully you recognize at least some of the brands on the PowerPoint. These brands are, in most respects, hold the number 1 or 2 market positions in the markets around the world where they are. And someone in our marketing group has come up with the figure of 250,000 of the world's population in a given day is using our product. I don't know if that's been proven scientifically. In terms of the sectors that our company operates in, we certainly have our household-oriented products, personal care, and consumer tissue. As you can imagine, those businesses depend heavily on raw materials. In the case of personal care, that's primarily polypropylene, polyethylene, petroleum-derived plastics. And then on the consumer tissue side, it's usually either eucalyptus, hardwood, or softwood from places like Canada and the Southeast. In our healthcare business, you may have seen purple surgical gloves that EMTs use, that surgeons use. That's trademarked for Kimberly-Clark. So we produce surgical garb, protective gear. We're very much in tune with the healthcare industry and in their efforts to deal with hospital-acquired infection. A lot of our products and solutions are geared toward preventing infection and certainly trying to minimize it where it comes. We also have a medical device business that's growing within Kimberly-Clark. KC Professional is you could probably call that an institutional and do-it-yourself business sector. In the building here, thankfully, and elsewhere on Capitol Hill here, a lot of the buildings do have some of our products, whether it's tissue or hand sanitizer, whatever it may be. Our do-it-yourself products like wipers that you use in an industrial setting and other protective gear, eye protection, ear protection, and so forth. We have a safety business that I'll mention later in that sector as well. Our California profile, our largest facility in California is in Orange County and Fullerton. We've been in operation there, as you can see, since 1955, 350 employees. The products they make primarily are products like this Scott Bath and this Kleenex Facial. They also make wipers for lab and scientific settings as well. That facility, and I'll highlight some of it later on, we think really embodies some of the advanced approach to manufacturing that some of the other panelists have suggested is important to look at. In Lake Forest in Orange County, we have the global headquarters for a medical device unit of our healthcare business, and they make products that are primarily in the pain management area, like this pain pump that you might see used is an epidural to supply anesthesia to an epidural device for pregnancy or for intravenous for an operation. 100 employees there. Again, those are headquartered type jobs focused on research and development and safety, regulatory affairs, some marketing. I think that one's also noteworthy because iFlow, which is the The company that this was, before we acquired it several years ago, is a California-founded company. In 1980, iFlow was founded in the state of California and moved to their Lake Forest location in 1997. We have a small manufacturing facility in Pomona that produces welding safety products, about 25 to 30 employees there. In Redlands in Ontario, have distribution centers dedicated to Kimberly-Clark, and then we have certainly a large number of people based in California who are salespeople for our company. This is just a quick slide to show you the old folks that founded Kimberly-Clark back in 1872. That's Mr. Kimberly, Mr. Clark, Mr. Shattuck there. One of the more interesting things about that center picture about Kotex is that we invented the feminine care category of product. Kotex emerged from, believe it or not, a World War I gauze field dressing production facility. And one of our enterprising employees decided that this may have some application, not just to deal with bleeding in a trauma situation, but to actually spur development of a product for women. So Kotex came from cotton texture product that we had developed, and that happened, this was 1912 when they first made this discovery. I'll have to join with the gentleman to my right here in suggesting, as you talk about what constitutes advanced manufacturing, that you give some introspection and precision to that definition. We think at Kimberly-Clark, our people that work at Kimberly-Clark are one of our primary indicators that we're advanced in the manufacturing that we do. Our Fullerton Mill is an organized facility. The Associated Western Pulp and Paper Workers, local, is the on-site union. And the backbone of that workforce at Fullerton is our hourly workforce. There's only a small percentage of those 350 jobs who are salaried people, and they're very much an empowered, self-directed part of our workforce. Any given time during a shift, you'll see near the machines in the control rooms, you will see hourly people doing that work, and with very little hands-on from the management team. We think that's the way you do manufacturing. The average annual compensation for our employees, for instance, at our Fullerton facility, since it's our largest, is just over $80,000, which is well above the average wage in Orange County in a lot of employment areas, industry sectors. We certainly believe in work-life balance. We have a wide array of healthcare-related programs and community involvement programs that incentivize our employees to work in the community. They can get reimbursed for volunteer work they do for local nonprofits, get matching grants, for charitable giving, and also we have a college scholarship program for our employees if their students have good academic work. The training that we do, as you might imagine, is continual. Our employees are expected to be able to work on the latest technology in our industry, which is constantly evolving. And I certainly wanted to give thanks to the state of California for the employment training panel incentive. We make great use of that every year. We'll keep sending applications until they turn us down. And we do approximately 30,000 hours of training for our employees at Fullerton every year to keep them current. Another aspect we think of an advanced manufacturing approach are the business processes, not just the technology you use, which is constantly having to change if you're going to be competitive, but also your approach to how employees interact with equipment and with one another. And even though we're not ISO certified yet at that facility in Fullerton, and we're still in the early stages of our lean journey, certainly our employees are giving great attention to getting a great amount of training on problem solving, not having to go up the management chain to address immediate issues, and also just daily accountability to make certain that every day our employees and management are focused on what the challenges are in the mill or in the plant that given day. I think the second part of advanced manufacturing certainly is the technology used, and also your stewardship of resources. Some of the other panelists referred to, how a company makes use of natural resources, of energy, other environmental and impacts in the world we do business, is a good measure of how advanced a company is in their approach. The first picture to the left on that slide is of our high-efficiency combined heat power cogeneration facility at our Fullerton mill. Energy, electricity in particular, as you all know, is expensive in California. And years ago, our Fullerton mill management convinced the company to basically take our energy matters into our own hands and make our own electricity on site. And 98% of what we consume is produced through this on-site facility. And also, the combined heat and power allows you to capture any waste heat off of a gas-fired turbine that produces electricity and channel it to some productive use rather than just venting into the air. And you have to have a lot of steam to make facial tissue and bath tissue. So it's a good arrangement for us. The picture to the right there is a solar array on the top of our Redlands distribution center. It produces about 10% of the electricity we use on site, and the remainder is exported to the grid. Production efficiency, fiber, whether it's using polymers to make diapers or tampons, or it's using wood fiber to produce some of these products. We've made great strides in the past 5 years with our manufacturing technology to be able to make product with less demand on those type resources. We're also doing a great deal of experimentation currently as a corporation in the area of alternative fibers, whether it's naturally derived polymers that don't compete using petroleum for fuel purposes, for instance, whether it's not necessarily corn, but algae, I should say, and other types of producing polymers. And then fiber, alternative fiber to, again, your garden variety, forest that you use for harvesting for softwood and hardwood. We're looking at that area. Our Fullerton mill is landfill free. We have no manufacturing waste that goes to landfill, or either we reclaim it and use it on site, or we either sell it or give it to an outside party for some type of beneficial use that does not involve a landfill. And with energy efficiency, self-sufficiency, I mentioned that briefly. These are just 3 recent ways that Kimberly-Clark has been recognized, indicating we think that we're a good corporate citizen in every way that we operate, whether it's employee relations, working conditions, our direct engagement in the community, and also in some of these environmental measures. We feel like, and then corporate governance in the case of the Ethisphere Institute's recognition. That's an increasing area that I know that policymakers are looking into to make sure corporations are accountable in the way they deal with shareholders and with their employees. Again, thank you for the opportunity. Happy to answer any questions if time allows.
Well, thank you all very much. Been very informative and inspiring series of presentations here. I want to welcome to the hearing Senator Kevin DeLone, who's been here for a while, taking in the content of what you've presented. Senator Emerson is still with us, and the other members, as you've seen, have been in and out. But I think, number one, I have a series of questions that I hope are informative for future policymaking and consideration of our committees. But I want to lead with a devil's advocate question, because I heard from a couple of you, you can't exist in California, you can't compete in the region or in the nation unless you have some of these advanced manufacturing attributes already in your process. So why the need then for any federal or state incentives for upgrades to or transition to advanced manufacturing? Professor?
So I'm least qualified to talk about the business, so I'll speak first. I think what you get from their presentations is the technology is not stable. I mean, the steel example was particularly impressive. I mean, I actually did my PhD in Wisconsin in the area of pulp and paper, so I know all these areas, machine tool industry, the technology advances constantly, just like your automobile technology, stereo technology, or cell phone technology. So you have to not rely on the fact that they'll do it on their own, or sort of try to spread it out and exist without incentives to keep moving. The technology for the training of the workforce, the technology for the use of the equipment, the technology for the replacement, and the costs keep changing. And I think that's probably the biggest reason why regions develop. You know, China developed tremendously because it didn't have a long legacy to do it, so you start from sort of a green field and get going. And I think that's, from my perspective, that would be one of the major reasons. If you think about aerospace industry and the tremendous differences over the last 10, 15, 20, 30 years, and just the way aircraft is manufactured, the other systems, it's not constant. So there has to be constant incentive to keep growing and keep attracting. And other people are watching what we're doing and learning from it.
Anything further from the others?
Well, I think that's a very interesting question. But again, you know, a lot of times a decision to be in a certain region or not to be is an economic decision long term. And there are certain things that drive people to defer those decisions for some period of time because you already have a position in a certain geographic location or whatnot. And sometimes the cost to move exceeds the benefit. But eventually things settle out, and when the slate is clean and your current manufacturing technology has become obsolete and is now outdated, profit margins continue to dwindle, and eventually you're going to make a decision to either renew where you're currently at or relocate. And I think over time, you'll see the continuing decline, and I think that's the biggest factor.
And I'll add another sort of a tweener. It's not always about whether a company stays or a company moves, or if a company sought to establish somewhere else or moved previously and is thinking about coming back. It's also companies that are growing. They'll continue to have the facility and capacity where they do, in-state, out-of-state, overseas, but as they see opportunity for growth, where they locate the growth is another strategic decision.
My point of saying everything is advanced was I would just like consideration to be made for all manufacturing, not just what is defined as advanced manufacturing, because I think you'll leave a lot out of the equation.
Yep.
If I could, Mr. Chairman, follow up Mr. Hansel's comment. There's, I won't mention the name of the company, and they were well within the rights to pursue, you know, a large incentive package, but there was a large tech company that got an excellent incentive package to locate a manufacturing facility in a particular state in the past 5 years. I can't be more vague. And the interesting thing about it was that the product, the end product of the manufacturing process was viewed as a technology product. But if you looked at the actual work that was being conducted in the facility, whether it's the skill level involved or the way and corresponding compensation level, the degree to which they're using technology to make product, it was actually fairly low tech. It was a light assembly soldering type operation. So I would just build a little bit on what some others have said, and that is that some of us would advocate that you look at some of those variables, is that let's not get caught up in the end product and whether we consider that to be definitive of what the value of that whole employment and investment picture is. Look at the value of the jobs, and the nature of the technology being used to manufacture is a key determinant.
No, and to that point, why we asked all of you the very question of the definition of advanced manufacturing, for you to comment on it, you know, to the extent that we want to put state incentives of some sort, fiscal or otherwise, on the table for industry. You know, it's one thing to say, well, you can define, you know, what a certain product may be, but that's not what we're talking about here. It's a process, it's a capability, it's a, you know, more of a, it's a little tougher to describe. But to the extent that we're limited resource-wise from being able to incent all manufacturers, given the reality of our budgets, how can we be as strategic, not just selective, but strategic as possible?
I would just say that, I think the long-term strategy is to lift all boats. And, you're never where you need to be competitive. It's always, you're running uphill. And if California doesn't incentivize those investments in this state, other states will in their states and are in their states. That's the reality of the situation.
So let me ask this. To the extent that you know, whether you personally or somebody else at your company, what level of involvement y'all have with the President's efforts, the Advanced Manufacturing Partnership? If you are involved, can you describe that a little bit? And if you're not, here's your chance to give one of the President's right-hand men some 2 cents here. What would be a recommendation you would give in the interest of your company, your field, and the state of California specifically? Who gets to go first?
Question? Well, let's see. A couple things I'll mention about the Boeing company and involvement. First of all,
Thanks. Just so you know, you have a Berkeley professor taking notes, okay?
Talked to his constituent earlier today, and so we're going to follow up on exactly how Boeing and they might work together. So just leave that. Yeah, leave that. Obviously, Boeing Company is the largest exporter in the United States, and our CEO works on the council for the president associated with that, and so we're very motivated from a company perspective and a corporate perspective to take advantage of anything and everything from the U.S. government perspective, from the state of California perspective.
But as they're still structuring it, because there's still details to be determined.
Absolutely.
What would we like to see in the final?
I'm going to take advantage of the best answers from these guys and then come back to you on that.
Okay.
I just think the point we're all making, most of us, I think at least, are convinced that it needs to be broad-based. Picking winners and losers is not the way to go. The overall economy would be much better helped by a program to invest in all of these industries because they're all necessary industries. They're all necessary industries. They're not, one is not better or worse than the other. You have to have all of them.
If I could, Mr. Chairman, one response. One of the other panelists had mentioned, the fact that California, unlike a lot of states, the majority of the states imposes a sales tax on inputs in the form of machinery and equipment. That, by its definition, is a business purchase that you're going to make, and the incentive you receive is not an upfront grant based on your promise to invest, but it is only accorded to you if you invest. And it sounds like from the presentation, these companies at the table are all in the category of investing not just to do better and do more, but frankly to just stay competitive. We're a capital-intensive business. We used to be labor-intensive. What has happened is the technology has increased, the amount of technology, and of course the productivity has gone up. And even though we're not as intensive in terms of the amount of labor, the quality of the jobs has gone up because we're increasingly asking more of them in terms of their skill level and their ability to contribute. We're not slotting people merely to work in a warehouse. These people are cross-trained wherever possible to work in a lot of different disciplines so they can increase their own compensation and grow professionally. So I think that'd be one area if the Senate, this committee, were willing to look at something. I think that might be one area to look at.
Okay.
I'd just like to see a lot of effort put toward the educational aspect. That may sound like a suck-up answer. Professor here, but it's something that we face, and like the gentleman here said, the quality of jobs is increasing. That means the skills necessary are increasing. So manufacturing being presented in a very positive light and educating the people properly to do the job is important.
So if I might just make a comment in response. So there were there were 3 other panels. One was dealing with education and workforce improvement. One was dealing with policy issues, sort of globally, or sort of tax code and things like that. And one was dealing with the shared infrastructures. I think there were regional meetings for AMP, which of course were set up in a very short time frame and didn't really have a chance to get a lot of people involved. And the one in California, I think, had a better representation of industry than some of the others. But I think it is basically then incumbent upon those of us, especially in California, to begin talking as a next phase with these types of representatives on specifically what can be done with existing capability. So education is something that we can already take advantage of without any kind of particular additional incentive. That's what our business is. Tuning it to what industry needs is always something that engineers are trying to do. And to take advantage of the kind of initiatives that are coming out of Washington